Hello everyone, my name is Muktis Parisha and on behalf of my team I will be presenting our research which is Automatic Overheat Early Detection System. Okay, let's start with the introduction. As we know that it is widely known that in industry field that the malfunction of mechanical machinery and electronic device is sometimes or frequently caused by a rise in the operating temperature or overheating of at least some portion of the equipment. So as we know that overheat temperature can actually damage the equipment and add cost to the maintenance. Thus, it is vital to add a system that can help detect overheating, prevent related issues, and ensure that machine capable of operating for a long period. So this proposed system, called as Machine Overheat Early Detection System, functions to detect temperature of device that reach the limit before overheat. This system also built with IoT function and three different features, which is cooling system, notification system, and cut-off system. So in particular way, this system is important in factories or industries consisting of large machinery where some intervention is very important in the event of overheating of the machine. So if you can see that on the right side, which is we have stated two main objectives. The first one is to monitor and make sure a machine will not operate in overheating condition and help to avoid damage to the component inside the machine. Second objective is to improve the current system and want to create a complete system by adding three features that can increase the functionality. The first feature is the cooling system by using fan and it will help to cool down the machine. Second feature is notification system. So in this section we having two kind of component, which is first is buzzer as to alert the surroundings, and second is node MCU as to send the message to the user through telegram if the machine is overheated. And the last one is cut-off system. We are using a relay module that can help cut off the supply of the machine if the machine is overheated. So before starting the project, we do literature survey, and these are the research paper that we went through. And the most common part that we observe is the method processing the data, and most of the project is using microcontroller, and this actually is the most popular one. But however, we decided to use a compact module which is Node MCU ESP8266 Wi-Fi module. So the module that we use is built with IoT function, and one more thing that we notice is the features, which most of the project is having between 1 to 2 features only. So for our project, we decided to improve the functionality and added more features so that it can give a better performance. Okay, this is the system overview. If you can see, it will start from the start symbol, which is referring to the power supply. So this system is using 12-volt power. So once the system is active, the first component, which is the DHT11 temperature sensor, will detect the value of the temperature and send to the node MCU. And this node MCU will analyze the data and then send to the display segment. And display segment will display the value. If the temperature is low, it will return back to the node MCU. If it is high, which is in the 23 Celsius range, the fan will start to active, which is it will cool down the system. If the temperature is at 33 Celsius, the buzzer will ring and the node MCU will send the message to the user. If you can see on the right side is the message. So if the temperature is at 43 Celsius, the relay module will cut off the machine automatically. This is the analysis graph. So if you can see that there are three different value temperature tested on the DHT11 sensor module and thermistor. So this graph shows that the sensitivity between DHT11 and thermistor. The DHT11 sensor module has been calibrated before the test was conducted to make sure that the measured temperature is correct. In detecting the incoming heat, DHT11 much more effective compared to the normal thermistor sensor. The sensitivity capability from DHT11 really helped the system detecting the heat come from any equipment where the sensor is attached or located. To simulate various reading of temperature, the heat source is in this testing come from the heat gun. So the DHT11 operating temperature is ranged between 0 to 50 Celsius. Hence, in order to avoid any damage to the sensor module, this maximum temperature has been set is at 43 Celsius. So if the requirement for this detector need to monitor higher temperature areas or equipment, the sensor can be changed with higher temperature range sensor module such as DHT22, which can detect up to 80 Celsius. So next is the result. So basically this project has 8 main components, which is the first one is the light indicator. So there are 3 different colors of light indicator, which is the first is the green. It will be on when temperature at 23 to 32.99 Celsius. Second LED is the yellow. It will be on when temperature at 33 Celsius to 42.99 Celsius. And the third LED is the red, which is it will be on when temperature at 43 to 80 Celsius. Next component is the node MCU. It used as sending message to user telegram. This is the telegram. Okay. Next is the buzzer. This used as the alert the surroundings. Next is the display segment. So this display segment will displaying the value of the temperature. Next is the relay module. So basically this relay module are used as a cut off the machine if the machine is overheated. And next is the fan. This fan is used as a cooling system for the machine. And lastly is the temperature sensor. This will help to detect the value of the temperature. Okay, for the first process, when temperature at 31.7 Celsius, the indicator green LED will turn on and the fan will cool down the machine. Okay, so when temperature is at 38.5 Celsius, the yellow LED will turn on and the fan will also turn on to cool down the machine, and the node MCU will send message to the user by telegram. This is the message, which is machine is overheat. Okay, last one is the third part, which is if the temperature is at 55.8 Celsius, the relay will cut off the machine. Okay, this is the last part, which is summary. So as we know that there are several parts of the proposed system device, which are 12-volt adapter to supply the power to the system, a fan system to cool down the component inside the machine, a buzzer as to alert the surroundings, node MCU to send the message to the user via Telegram app if the machine is overheated, a relay module to cut off the power supply to the machine if the temperature reaches the limit of operation level. So this system, which is automatic overheat early detection system, has been set with the minimum and maximum temperature. So in this system, the user is able to set the desired temperature for the system to monitor based on the local requirement. So a humidity and temperature sensor, which is DHT11, function to monitor and detect the value of temperature and humidity, which is then displayed on the LCD screen. To illustrate, if suddenly the temperature of the machine is at the maximum level, which is 43 Celsius, the relay will automatically cut off the machine power supply, where it means that the machine cannot operate or function. So based on this elaboration, the prototype has 3 features or advantage, which are a cooling system, notification system, and cut-off system. These features were designed in order to avoid the machine from operating at high temperature, as it can damage the electronic component. So it can be said that this system can be used or installed in any equipment. Thank you for watching my presentation.